So this is the math from Streamflow. Uh, we have a river that is Chelsea River. Uh, we have discharge for some particular stages. We'll develop a relationships between stage and discharge. We know that the relationship between stage and discharge is Q is equal to constant, let's say C H, that is stage minus 2 bar ধরুন ছবি না তুললাম। So this is the math of stage-discharge relationship. So a particular river, that is Chalti River, I misspelled that. We have stage, and for that stage we have discharge. And we know that the relationship between stage and discharge is Q is equal to this discharge is equals to a constant C multiplied by stage subtracted by the stage at zero discharge, which is A, to the power B. We can take log at both sides, so I'll get log Q is equal to log C plus B log H minus N. So I will take this as Y and log H minus A as X, and this is my M and this is my C. So now the thing is, we'll draw uh, a curve, and from that curve we'll find the parameters. So for that, if that is Q and that is my stage H, I will find out first of all log Q, and then I will find out uh, log H minus A. Say log H minus A. Here the A is 1.6 meter, which is the stage at zero distance. So A is what we know, 1.6 meter. So if I take log 10 based, I'll get some values, that is 2.5, 2.65, 2.76, 2.81, 2.91, 2.95, 2.99, 3.04, 3.11. And for log h minus a, I will get value of 0.45, that is 0.56. Oh god, that's 0.56, and that is 0.65, that is 0.69, that is 0.85, that is 0.87, that is 0.88, that is 0.9 also, that is 0.81. So I'll draw a curve. From that curve I will find out the parameters. Well, we'll draw, we'll take points of log h minus a in this axis and log q in this axis. And these from there I will find out stage-discharge relationship. Say this is point 4. I will have to go the highest value of h minus log h minus a is 0.81. The lowest one is zero point 0.4, and the for q log q, the lowest point is 2.5 and the highest point is 3.1. So what I can do, I can take this as 1, this is 2, this is 3, this is 4, and here I can take it as point 4, this is as point 5, this is as point 6, this is as point 7, this is as point 8, and this is point 9. I'll plot few points, not all the points. As this has been a manipulated data, everything will fall on the straight line. So let's take this value like 0.45. I will plot, let's say, few points like this points 0.45 to point 0.5. Later, let's say I want to plot 4.65, this one 2.76. Let's say I want to plot 0.9, 3.04. And for you, you will draw all the points. But for me, I'll draw few points. So my first point is 0.45. Let's say here 0.45, and for that I'll get 2.5, which is exactly this point. Let's mark this. This has been very big. I don't want this that big. Oh god, this. Later, let's say 0.65. For 0.65, I had a value of 2.76. 0.65 is this, and I have a value of 2.76. So it would be 2.5, it would be 2.67, and 6 would be somewhere over here. So this. So it's been too large actually. 2.76 here, just over here. And the later one is, let's say, for 4.9, I've got a value of 3 point, just above 3, which was 3.04. So 3.043, and there is 3.1, and there will be in between, so this point. So let's draw a straight line. You'll take all the points and draw a, what can I say, draw a best fit curve, maybe. Let's say it will go like this, and it has been a bit up. I will make it a bit. Oh god, what's happening? I'll bring it a bit down like this. Let's say it's like this, and I'll bring it a bit up. Let's say like this. Well, fine. We do it. So from that, I'll get the values so that I can get the slope. Let's say I have a point over here. Let's say I have this point, and let's say I have another point at here, uh, like here, this, maybe these and these two points. I don't want this point, this point. So for this point, I'll get a value of 0.55, and the height would be 3 point, sorry, 2 point, 2.56, 2.5, sorry, 2.6, this 6, 2.6. And maybe for this one, maybe I have got a value of, I can take it as 0.79, 0.79 in x-axis, and y-axis I've got a value of, let's say this is 2.9. From that, I'll get a slope. Say the slope is 2.9 minus 2.6 over 0.79 minus 0.55. The slope would be 2.9 minus 2.6 over 0.79 minus 0.55. That is actually 1.25. Uh, I did it previously. I need a slope of around 1. So you just do a little bit of modification, and let's say the slope is say 1. You'll do a little bit of modification, and for that you get a slope. And for C, let's say it has crossed over here, and say the value is around, say the value here is, although this is looking 2.3, let's say it is 2.25. So for that you'll get a C value of log C is 2.25. For C you'll get 10 to the power 2.25. You'll get a value of 10 to the power 2.25, and you'll get a value of 177.8. So your equation is now here. Q is Q, your C value is 177.8, and your H value is variable, and A is 1.6, and B is still 1. So I didn't take it as 1.25 because it will generate a value very high. So when you're doing this in exams, you cross check that your values is satisfactory. Let's say you want to take uh, discharge for 7.7 and put the value of H is equal to 7.7. See what happens. 177.8, H is 7.7, and A is 1.6, and you have a 1. So you get a value of here 184. So you should get a lower value. It has a difference of around 100. So this value should get a bit more lower. So you'll draw more points, you'll draw a base fit curve, you'll shuffle so that the values you're getting, or the relationships you're getting, represents the actual distance what you have. So this is all from this lecture.